Okay, in this video, we will be discussing linked lists. So here I've written the definition, the formal definition of a linked list. Let's try to understand each of these terms given here. So linked list, what I'm saying is a linked list is a linear, homogeneous, ordered collection of nodes. Now each of these terms is very important. So why am I saying that a linked list is linear? A linked list is linear because, like I mentioned in the previous video, it is a linear data structure. That means you will be storing elements of a linked list in a straight line fashion. That is why it is being said that linked list is linear, because it is a linear data structure and elements will be stored in a straight line fashion. Next is homogeneous. Homogeneous means you will have a linked list of items or a linked list of values which are of the same type. That means you can have a linked list of integers or a linked list of characters or a linked list of strings, but you can never have a linked list of integers and characters or integers and floating point values. All the values that are stored in a linked list, they will have to be of the same type. They will either be all of type int, all of type float, all of type double, and so on. Next is, it is an ordered collection. So why is it an ordered collection? It is an ordered collection because the order in which my nodes appear in a linked list or the order in which the data values appear in a linked list is important. Okay, the order in which the data values appear in a linked list is important. And it is made up of nodes. The fundamental unit of any linked list, there are three types of linked lists, right? A single linked list, a double linked list, and a circular linked list. You take any of these linked lists, they'll all be made up of nodes. So a node is a fundamental unit of a linked list. Like we saw from the previous video in which we classified the data structures, we saw that a linked list is of three types. It is either a singly linked list, it is sometimes also called single linked list, or it is a doubly linked list, or it is a circular linked list, right? Now all these three types, they are all linear, they are all homogeneous, and they are all ordered collections. Then where do they differ? These three types of linked lists, singly linked list, doubly linked list, and circular linked list, they all differ in the way we define our nodes. These three linked lists are different in terms of the node format. Okay, in terms of the node format. So let's see the node format for each of these types. So let's start with a singly linked list. So node format of a singly linked list. This is the node format of a singly linked list. I'm writing singly linked list in short as SLL. I'll be using this notation in other videos as well, so you can make a note of this. SLL stands for singly linked list or single linked list. Now the node format, in every node of a singly linked list, there will be two parts. The first part is my data. That means the value that I'm trying to store in the linked list will go in this data part. And the next part is the link. What is the link part? The link part will contain the address to the next node. See, merely creating nodes is not enough. If you're trying to build a linked list, alongside creating nodes, you will have to link the nodes together so that the collection can be complete. Now, in order to link the nodes, we have a link part for every single linked list. Now, what about the node format for a doubly linked list? The node format of a doubly linked list is something like this. So you have a data part, you have a right link. So you'll have two link parts, right? You will have two link parts, and you'll also have a left link. So this is the node format for a doubly linked list. This is the node format for a doubly linked list. I'll not be drawing the node format for a circular linked list because a circular linked list can either be a circular doubly linked list, or it can be a circular singly linked list. Then what is the difference between a circular linked list and singly linked list and doubly linked list? See, in a singly linked list, the last node, the last node will have its link part as null. Okay, what I'll do is, in the next video, I'll show you an example, or let's say with the help of a diagram, I'll show you how each of these linked lists vary. For now, you just concentrate on the node part. The node format, as you can see, so there is a data part and a link part. Here you will have two link parts, and here you will have a data part in between. So the actual value that you're trying to store in a linked list will go in the data part, and the right link will contain the address of the next node, and the left link will contain the address of the preceding node. Okay, so I guess that was all about it. Now, before I conclude, a question that is often asked is, why is singly linked list so named? Okay, or why is a doubly linked list so named? Why would you call a singly linked list a singly linked list? Or why would you call a doubly linked list a doubly linked list? The reason is this part. The reason is the link part. See, look at the node format of a singly linked list. In a singly linked list, in a node of a singly linked list, there is only one link part. That is why it is called a singly linked list, because there is a single link part. There is a single link part. For a doubly linked list, there are two link parts. That means double link parts. That's why it is called a doubly linked list. So this question is, it's often asked that why is a single linked list so named, or why is a doubly linked list so named? It has to do with the link part. So if you have a single link part, then it is called a singly linked list. If you have two link parts, then it's called a doubly linked list. I'll see you in the next video. Thank you.